Okay, we're going to talk a little more today about the zeros of polynomial functions. When you're finding the zeros of a polynomial function, what kind of numbers can I get? Okay. So here's a polynomial that's in completely factored form. I factored it as much as possible. Okay. All the factors are linear, and that just means that the x's have exponents of 1. That's what linear means. Okay. So I want to find all the zeros of this polynomial, and I want to classify each of them as real, non-real, imaginary. Let's just do real and non-real. And rational and irrational. That's craziness. We don't need all that. An imaginary zero. So if when you're factoring it, you might end up with an imaginary zero. Yeah. It doesn't live in the graph of the function because the graph is just real numbers, x and y. So you can't see it like an x-intercept, right? You can see the real zeros in the graph. You can't see an imaginary zero. One of the reasons we call it imaginary. Like an imaginary friend. Can't see it. Just have to know it's there. Okay, so if I'm looking for zeros of this thing, right? If x plus 3 is a factor, what's a zero? -3. And it's actually a 0 2 times, right? Because that x plus 3 is a factor twice. So I'll put multiplicity 2 here. So it actually is a 0 2 times. And if 2x minus 1 is a factor, what is a 0? 1/2. X plus root 2 is a 0. That means is a factor. What is a 0? -√2. X minus root 2 is a factor, means root 2 has to be a 0. If x minus 4 plus 5i is a 0, is a factor, what has to be a 0? Four plus 5i. Whatever x minus whatever is your factor, that whatever is your 0. And if x minus 4 minus 5i is a factor, that means that, we gotta actually have to be a little bit more careful with this. I'll do a little side work over here. If x minus 4 plus 5i equals 0, right? Because when you're finding the zeros of a function, you factor it all out, and then you take each factor, set it equal to 0, and solve, right? So it turns out that x equals 4 minus 5i is actually a 0. I add 4 to both sides and subtract 5i from both sides. So I have 4 minus 5i is a 0. And then if x minus 4 minus 5i is a factor, what would have to be a 0? 4 plus 5i. Okay, so -3. Is that a real number or a non-real number? Real. Is it rational or irrational? Rational. Yeah, because it can be written as a ratio of 2 whole numbers. That's what rational means. Yeah. -3, I'm classifying it as real or non-real. There's no i's in there, so it's real, right? And it's a rational number because it can be written as a ratio of 2 whole numbers. All right, 1/2, real or non-real? Real. Rational or irrational? Rational. Real, rational. -√2, is that real or non-real? It's real. Non-real means there's i's in the answer somewhere, right? So this is real. Is it rational or irrational? Irrational. Yep. So this is real, but irrational. Same thing with √2. Positive √2. Now 4 minus 5i and 4 plus 5i, what are those? Real or non-real? Non-real. And then when it's non-real, you don't even have to bother asking rational or irrational. That only applies to real numbers. What is the degree of this polynomial? Seven. Yeah. The degree is what the highest power of x you would get if you multiplied all these factors together. So I have an x squared, and then I have x, 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 all being multiplied together. And when you multiply, you add the exponents. So you can just add the exponents that are in all those factors. So this is a 7th degree polynomial. How many linear factors does this polynomial have? Close. Close. 7. X plus 3 is a factor twice, so we say it has 7 linear factors. That's just a leading coefficient. The linear factors all look like something like mx plus b. Yeah. So it has 7 linear factors. Oh, look, its degree is 7 and it has 7 linear factors. How many zeros does it have if you count multiple zeros as multiple zeros? 7. Yeah, because the -3 is actually, it happens twice. So it's got 7 zeros. It's not a coincidence. The degree of a polynomial is always the number of linear factors it has and the number of zeros it has. If you count the multiplicities and the non-real zeros, right? Because before today, we weren't coming up with the non-real zeros. If you count the non-real zeros, it'll always add up to the degree. Okay, so let's look at this cubic. X cubed plus x squared minus 5x minus 2. We're going to find the exact values of all of the zeros of this polynomial, and we're going to write it in completely factored form. So in general, to find the zeros of a polynomial, or any function, you set the function equal to 0 and solve. Why? Why is that the procedure? Yeah, I mean, that's the definition of a zero, places where the function equals 0. So we're going to use a graphing calculator to find one nice integer valued 0 of the polynomial. Because I know you don't all have one in front of you at this moment, I graphed this cubic. I went to y1, I typed it in, and I got a graph. And I said, oh, look, it has a nice integer 0 at 2, right? It's got a nice x-intercept and a nice whole number 2. Okay, so I have x equals 2 is a 0, right? So now that I have a 0, I also have a factor, right? 2 for the price of 1. What is the factor? X minus 2. Yep. And then we can use polynomial long division to find another factor. So the graph helps me find the first factor. I can use division to find another. What do you think the resulting factor will, what degree do you think it will have? If I'm starting with a cubic and I'm dividing by a linear 2, it's going to have a degree of 2. Yep, degree 2. Yep. Oh, don't even worry about it. It's a shortcut for a polynomial long division. But the thing with polynomial long division is that you'll use it so infrequently that learning another method, even if it's shorter, is going to take more time than it saves you. Yeah. Yeah. Well, I didn't ask you to do it using synthetic division, did I? In the homework? Just that the like help me solve this used it? Yeah. Yeah. Yep. Okay, so I need to divide x cubed plus x squared minus 5x minus 2 divided by the one factor I know, x minus 2. So I say, okay, what do I multiply x by to make x cubed? X squared. And then you have to multiply that x squared times the x minus 2. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. And then I subtract. And I have to be careful about the signs here. X cubed minus x cubed goes away. And then I have x squared minus negative 2x squared. So that comes to 3x squared. Bring down the minus 5x. And then you start again. What do you multiply x by to make 3x squared? Three what? X plus 3x. So 3x times x is 3x squared. 3x times negative 2 is negative 6x. And I subtract. So negative 5 minus negative 6 is just an x. Bring down the 2. How many times does x minus 2 go into x minus 2? Once. 1 times x minus 2 is x minus 2. Subtract 0. I'm done. Okay. All right, so there we go. I did my division. I have another factor. So now I have two factors. I know that I can rewrite x cubed plus x squared minus 5x minus 2 as x minus 2 times this quadratic. Okay, so let's just write it out. X cubed plus x squared minus 5x minus 2. We now know that this can be written as x minus 2 times the result of the division, which was x squared plus 3x plus 1. Does that make sense? When you divide, what you get as an answer, multiply it by the divisor, you get the thing you started with. All right, so our goal from part A, right, we had a goal. What was it? Find the zeros of the polynomial, right? You set the polynomial equal to 0 and solve it. Okay, so now I'm going to set the function that is now written as the product of two factors, x minus 2 times x squared plus 3x plus 1. Now set that equal to 0. This is the original function I was given, it's just written now in factored form. And because I'm multiplying two things together and the answer is 0, I know either x minus 2 is 0 or x squared plus 3x plus 1 is 0. This one gives me x equals 2, right? I knew that. Found that on my calculator. How do I solve this one? X squared plus 3x plus 1 equals 0. Factor it. You could try to factor it. It's not factorable. Quadratic formula. Yeah, you can use the quadratic formula. So I would solve this with the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's going to be negative 3 plus or minus the square root. So b squared is 9. And then 4 times 1 is 4, so maybe left with a 5 under there. 3 plus or minus radical 5 all over 2 times 1. So there are my other two zeros, right? I started with a cubic polynomial, which meant that I should have come up with 3 zeros. And the 3 zeros are 2, negative 3 plus radical 5 over 2, and negative 3 minus radical 5 over 2. So now that I have the 3 zeros, I know the 3 factors. I can write this in completely factored form, where I use all linear factors. So I'm going to have x minus 2, x minus this mess, negative 3 plus radical 5 over 2, and x minus negative 3 minus radical 5 over 2. Completely factored form. Yes.
So I know you're usually pretty lenient with answering form, but
yeah.
There's a radical and denominator.
No, radicals and denominators are fine with me. Yeah. All right, what was the degree of this polynomial? 3, yep. And how many linear factors does it have? Now that I just wrote it with linear factors? 3. How many zeros does it have? 3. Okay. So conclusions. Yes, question. Oh, so like this is a factored form of the original function. I wrote it as a product of two things, but x minus 2 is linear, and x squared plus 3x plus 1 is quadratic. So if I wanted to do it in all linear factors, I would have to factor that more. So it just means I don't want to have any exponents other than 1 in my factors. That make sense? Yeah. Okay. Okay, so my conclusions. If a polynomial function has degree n, then if you count multiple roots separately, the equation has exactly n complex zeros. So you're counting real and non-real. An nth degree polynomial can be expressed as the product of some constant plus n times n linear factors, where each linear factor looks like x minus c, and c is a zero of the function. A plus bi is a zero of the polynomial function. If a plus bi is a zero, then a minus bi is also a zero. That is, imaginary roots, when they exist, always occur in conjugate pairs. So let's go back to where we saw imaginary roots. Here we go. We had 4 minus 5i and 4 plus 5i occurred in conjugate pairs. And that happens because of the quadratic formula, right? You're always going to have something plus or minus something else. So if you have an imaginary zero, it's going to be a plus or minus b, right? bi. Both of them will be zeros. And irrational zeros also occur in conjugate pairs. 1 plus root 2 and 1 minus root 2, like we got in our example up here, right? Negative 3 plus 5 over 2 and negative 3 minus 5 over 2. Again, that happens because of the quadratic formula. Okay, one more problem that we'll do together, and I think it might even help you on your quiz a little bit, if this problem makes sense. Okay, so we want to find a third degree polynomial, f of x. It's going to have real coefficients. It has negative 3 and it has I as zeros. And f of 1 equals 8. All right, so they gave me zeros, right? So let's write this down. Zeros are negative 3 and I. Okay. It's a cubic polynomial. We're looking for a third degree polynomial. So how many zeros should it have in total? 3. But they only gave me 2, right? But you know that I should be positive and negative because complex zeros always occur in conjugate pairs. So if I is a 0, so is negative I, right? 0 plus I and 0 minus I should both be zeros. You're not going to have any complex things on your quiz, but this general procedure of finding a polynomial, translating zeros to factors, is on there. All right, so now I have my 3 zeros because it's a cubic. I should have 3 zeros. I found them all. Okay, so I can now say what my factors are. X plus 3, x minus I, x minus negative I, which is x plus I. So I've got factors. What I don't know is the leading coefficient, right? So this is the part where people tend to stop here and forget that there's another step, right? So my cubic function, f of x, it's going to be a, some unknown leading coefficient, times the linear factors, x minus 3, x minus I, x plus I. And then how could I figure out what that a value is? because f of 1 is 8. Plug in 1 for x, 1 for all the x's, 8 for y. 1 plus 3, 1 minus I, 1 plus I, and now I got to solve for a. So first thing I'm going to do is I'm going to FOIL out 1 minus I, 1 plus I. So that's going to be 1 plus I minus I squared. That's a 4. And then my plus I and my minus I cancel, right? Those are add to 0. What's I squared again? -1. So this is 1 minus -1. And 1 minus -1 is 1 minus -1 is 2. So I have 8 is equal to a times 4 times 2. So what is a equal in this case? 1. Four times 2 is 8, and I just divided both sides by 8. So in this case, a is just 1, which means that f of x, my final function, is x plus 3, x minus I, x plus I. That's my factored form. That's my completely factored form, but they also asked me to also put it in standard polynomial form. How do I do that? Just multiply everything together, yeah. So I'm going to keep my x plus 3 for a second. I'm going to multiply x minus I, x plus I first, because I know those things are conjugates, and it's going to come out to x squared plus 1. You can FOIL it out if you're not sure why that is, you would see. And then I FOIL x plus 3 times x squared plus 1, and I get x cubed plus x plus 3x squared plus 3.